Driver license, they are numbers, but not quantities. They are more of name, so it's even nominal, qualitative and nominal. Time it takes to complete an exam is the duration. So that one is ratio. Time for the exam to start or time you will end the exam, those are intervals. Age grouping as young, middle age, and senior, these are qualitative and ordinal. Your measure is qualitative and nominal. So when you select 5 zip codes at random and use all the members in each zip code, it is cluster. Every 50th apartment, that's systematic. Number all the units in the area and use a random number table. That is simple random sampling. Divide subscriber of a magazine into 3 different income categories. That's stratified sampling. So on quotient 3, the first one is an experiment. You are using a group and the other group you give a placebo. This is an experiment. When you use a computer graphic to determine the flight path, it is simulation. Whenever you use computer graphic, it is simulation. So this is about take-home problem 1. There was not much difficulty here, and if you have a question, you can always, yes. Exam will be the same format. And then yes. You will use Excel, you will use your note, you will do everything like at home. But you will do it in class because you don't communicate. That's the difference. So I will be checking, don't communicate with somebody online or any way. That's what is not allowed. So as you see the format, as you see how the answers are on these take-home problems, that is what I expect you to do too. So you will just type your answer if you like. I will bring paper for those who don't want to type, but I think typing is much faster than copying everything. So you can use the paper for rough work if you like, but I still think that, so in take-home problem 2, we have the data values here. So we enter this data into Excel. Because we want to make a frequency distribution table. So we don't want to know what is the lowest and the highest data value. So I'll enter the value here in Excel. You can use your calculator as well. But the calculator is not going to do as much as Excel at this point. So we have this data value here. The next step is to compute the range in order to find the width. Compute the range, we want to identify the highest data value and the lowest data value. So I will highlight this data and then sort it. So we can see here that the lowest data value is 19 and the highest data value is 93. So we use it to compute the width. It was require 5 classes, highest minus lowest, 93 minus 19 over 5. That gives us 14.8. Now we will round up to 15. So the width here is 15. To construct the first class, the lower class limit is 19, and the upper class limit is 19 plus the width, which is 15 minus 1. That gives us 33. So that is how we get here 19 to 33. For subsequent classes, we just add the width to lower and upper to get the next lower and upper. If you have question about that, please ask. Class boundaries are obtained by subtracting half of the unit, their whole number, 2.5, to the lower value, add it to the upper value. Yes. Yeah, the lower value of the second class is lower value of the first class, 19, plus 15, 34. So the lower value is 34. The upper value is upper value of the first class, 33, plus 15, 48. Then for the third class, you add 15 to both numbers of the second class to get the third class. Or you may just get all the first class, the first value, 19 plus 15, 34, 34 plus 15, 49, 49 plus 15, 63, 63 plus 15, 79. Then you go to the second one, 33 plus 15, 48 plus 15, 63. And so on. Yeah. So the class midpoint is the average of the two numbers, either on class width or order of class limit or class boundaries. If you take the average, you will get the same number. That is adding the two numbers and divide by 2. Then for the frequency, we are going to go back to Excel. So column A, we put the data values. Column B, we are going to put the bin. That is the upper class boundaries. We started with 33.5, 48.5, 53.5, 78.5, 93.5. So what Excel is going to do is to count the number of values that are less than 33.5 and then greater than 33.5 but less than 48.5 and so on. So we will go to data, then data analysis. Do you all still have data analysis on your laptop? Just check. Okay. Unless you reset your laptop, it will not go. But sometimes there is some manipulation you might do that it will go. Then it will come back again. When you do another manipulation, it will come back. So I don't know what exactly you do, but not if you reset, you are going to go through the options as we did at the beginning. But if you don't reset, you might just put off your computer and put it on or restart it and it will come back. So now we go to data analysis and we will try to construct a histogram. So histogram. Now the input range here, I know is A1 to A24. You can highlight it or you just list it. The bin is B1 to B24. So I want the range, I will just place it here. If I want at this point to get the histogram, I will click chart out. So it gives us the frequencies together with the histogram. So the values that are on the histogram are the upper value. If you like, you can add the lower value, 18.5, 32.5. So yes. If you have the time, just add it so that it looks nicer. What's important is for me to get this histogram. So as I said before, some people don't like so much space in between. To reduce the gap, we right click and choose format, and then we can reduce it as much as we want. So we have the frequency. We will come and complete our table on Word. With the frequency that are here. The relative frequency is frequency divided by sample size. So you divide this column by 24 to get these numbers. Cumulative frequency is the number of values that are less than or equal to the upper class value. So how many values are less than or equal to 33.5? We have 3. How many values are less than 48.5? We do 7 plus 3, 10. How many values are less than 63.5? We do 10 plus 8, 18. Then 4 plus 18, 22. You just keep adding the frequency to the previous cumulative frequency. So this is how we get the frequency distribution table. The most difficult part is the frequency, which for 20 values you can manually count. But if you have 1,000 values, that will be difficult. So that's why I want you to learn Excel, because it makes it much easier for you. And the histogram is here. Now the OGIF, which is the cumulative percentage graph. So we will go back to Excel. I will copy this and I will place it somewhere else. So I will start with the lower class boundaries and put 0 there so that I get a good complete ogive. So that was 18.5. I didn't copy this. So what I just did is copy the class boundaries, the one of them. The lower class boundary of the first class is the upper class boundary of all the values that are below it. We want to account for that. How many data values are less than 18.5? Look at the table here. How many data values are less than 18.5? 0. So we are going to put 0 here. Then we will have 3. These are the cumulative frequency. This is to make that cumulative percentage graph, the cumulative graph, which is the ogive. So I'm going to highlight, just like all graphs that we have been doing, you put the data value and the frequency. We highlight it, insert, and we want to choose a line segment graph. This is a line segment graph. We choose more line segments. And this is a good one. Not this. So this is the ogive. The next question is to construct a frequency distribution table for qualitative data. You write each category, the frequency associated with it, and then the percentage for describing the proportion for that category. So to make a Pareto chart for this, you only need the data and the frequency. You can just type it, because sometimes you spend more time, I spend more time, you might not manipulating, copying and paste. So I have the data here on Excel, but to make a Pareto chart, we want the bars to be descending. So for that reason, there are many ways of arranging this. I want to stick on one all the time, that is sorting it. So I will right click here. This is just to sort so that the frequency should be arranged from largest to smallest. It will want to know if it will also change the category, which I will say yes. So if I have this, suppose I have this and I want to make percentage here, this is one way to make percentage. Just do B1. Oh no, you need to know the sum. What is the sum here? will take the sum. You don't need to do this because when you do a Pareto chart, you can choose one of those Pareto chart. I'm sorry, the pie graph will give you the percentage. I'm just saying in case you want to make your percentage using Excel. So you should know the total and then divide this number by that total, by this one. So that is another way to find the percentage. Something went wrong here. I will not. You can also do the same thing here, equal to this number divided by this number. I'm dividing by the total, which you can do manually. This is not necessary, please. This is not necessary for Pareto chart. I did it because I'm already on Excel and I just show you those percentage when we were there. This is how you can get it. You can use your calculator and do it as well. So for the Pareto chart, I don't, yes. We need the percentage for the frequency distribution table. So now for the Pareto chart, we will highlight this and then insert and choose a vertical bar. This is not right. Sorry for this. I highlighted more than what I needed. Insert. This is the Pareto chart. And you can add the number. You can choose whichever one you want here. We can also do the next question will be the pie chart. Insert pie. And I like this one because it gives you both. It gives you the percentages. Or you can choose the next graph is the time series graph. I'll choose another sheet for that time series graph. Here, the air pollution index in Denver for each day of the second week of February is shown below. I can just write here, day 1. Let me just replicate. You can type day 1, day 2, day 3, and day 7. Then we enter the values here. 1.7, 2.4, 5.3, 4.1, 3.2, 2.5. This is the air pollution index. We are going to make a graph. This, we have to remember that the time series graph is a line segment graph. So we will highlight the values and choose, this is line segment. And just choose this. Last question is about stem and leaf display. We just choose the first digit as the stem and the second as the leaf. Arrange it in order. The advantage of it is that we can answer questions about frequency, how many values are, for example, how many values are less than 34. We can count 1, 6, 21, 26, 29, 33 are all less than 34. So that is take home problem 2. So you will have access to all this on your exam, but don't rely on reading all these things on the day of the exam. You should know how to do everything without looking. And then when you forget, that's when you look. If you think you are going to study on the day of the exam, you will run out of time. And I begin to subtract 1 point for each minute because out of 100. So when I give you 1 hour, 15 minutes, I set exam for 60 minutes. I give you 75 minutes. When you go beyond that 75 minutes, I know. And I will, at the end, I will subtract that, the number of minutes you exceeded. So practice and be sure what you want to do. If you want to be typing, get used to typing. If you want to be writing, get used to writing. Don't spend time there doing both and then you don't know at the end which one to submit. Submitting is just like you have been doing on your take-home problems and homework. So, almost done. Take-home problem 3. In take-home problem 3, we have this data value that we will enter on Excel again. We will be asked to find the mean, the mode, the median, the variance, and the standard deviation. That's the first question. We want the range, the variance, the standard deviation, and then we will use it to find the coefficient of variation and then the proportion of values that are within 2, 3, or 4 standard deviation, depending on the question. So we have 9, 12, 15, 11, 8, 10, 7. So these are the values. To answer that question using Excel, we are going to use descriptive statistics or that data analysis. We go to data and data analysis, non-descriptive statistics. You can also use your calculator, of course. Then we will highlight the value is from A1 to A20. Or you highlight it here. Output. Put it here. I need the summary statistic. This box is check summary statistics. I did the wrong thing, not completely wrong, but I like that the result should be on the side here. I went and clicked new workbook. That's why it went to a new workbook. So I like it here. So you can copy this and paste it on your Word document or just report the answers. You can report the answers here. If you click and paste, you will have this. You report your answers. The next question will be to find the coefficient of variation. You want to provide the answers as you see me doing it here. Don't just leave this box. You don't even need to put this box here. But if you put it, you are not doing anything wrong. But even if you put it, I want you to give me answers to these questions here, because there are more than what we need. I want to make sure you can read and identify where the mean is, where the variance is, and where the standard deviation is. So the coefficient of variation is the standard deviation, which is 3.25, divided by the mean, which is 10.55. You can use yes. Sample. I don't ask you for population. You do that on homework, but for no confusion, all my questions is about sample. If I remember, I will find a sample mean, but I don't want to be typing sample mean, sample median, sample. Everything we do is about sample, okay? If you're using your calculator, sample is SX for standard deviation. To get the variance from the standard deviation, square the standard deviation if you are using calculator. The standard deviation here is 3.25. Round up to 2 decimal places if you have too many of them, or 1, but not less than 1 if you have full numbers. So don't say this is 3. The standard deviation is 3. No, that's not right. So you should move at least 1 more standard deviation than the regular data. So for the Chebyshev inequality, if we want to be within 1 standard deviation, we subtract a standard deviation from the mean, add it to the mean. The range of values you have is the interval within which you expect 1 standard deviation to be. If it is 2 standard deviation, multiply the standard deviation by 2, like we are doing here. 2 times 3.25 is 6.5. Subtract it from the mean, add it to the mean, and you will get what we have here, subtracting 4.05, adding 17.05. Now we can go back to our data and determine the proportion of values that are within that range. So to do that determination, we want to sort this one in order. smallest to largest. How many values are more than 4.05 and less than 17.05? More than 4.05, less than 17.05. Out of these 20 values, how many? 19. So 19 out of 20 times 100 gives us the proportion of values that are within 2 standard deviations from the mean. Is it consistent with the Chebyshev theorem? It is consistent because it is at least 75%. If it was 3, Chebyshev will be, if you already have at least 95%, if you have 95% within 2, you will have more than that within 3, right? Okay. So they should already be there. Let me just make sure I do it now. Welcome. So you can check it. So the next question is adding a number to all the value, the same number to all the values, and then do the same computation to see what you are going to get. So let's do that. Let's say we are going to add 4, or let's add any number. I say 3 there. That's an example. We can say 4. No, there is 4 here. Let's say 5 equals to A4 plus 5. I added 5. I'll add 5 to each of the numbers in this data set. So this is my new data set. Then I want to use data analysis to compute the statistic again for the new data set. Now B1 to B20. I should change this one and put it here. So what happened to the mean? Are the mean the same? What happened to the mean? The mean increased by 5. If you add 3, it will increase by 3. What about the standard, the variance? Look at the variance here. They remain the same. So if something is vary in a certain pattern, if you add the same number to all, they will move up and still vary the same way. So the variance does not change by adding something to it. Do you think the standard deviation will change? The standard deviation is the square root of the variance. So if the variance does not change, the standard deviation will not change. So next set of exercise is to find the box plot, the 5 number summaries, and the box plot. I want to move to Excel again. And then I'll enter the values in column A, 18, 25, 32, 16, 41, 52. $47.56. 19, 22, 28, 15, 46, 23, 49, 52, 57, 56, 72, 19. So we have these values, and we want to first 5-number summary, that is Q, minimum, Q1, Q2, Q3, and maximum. We will start with the median. But before we do that, we will sort our values from smallest to largest. How many data values do we have? 27. So the middle will be at 27 plus 1 over 2. That is 14. 28 over 2, 14. So this number, the way I arrange it, that's why because I started from 1. So you want to know where you start. So the median here is 33, which is Q2. So Q2, 33. Now, below the median, we have 13 values. 13 plus 1 over 2 give us 7. That is 14 divided by 7. So the 7 value is Q1. Then the 21st value is Q3. So the maximum is 72. So then we get the 5-number summary. Now, if we do the box plot, it will also give us those numbers. Box plot, the box and whisker plot, you go to Insert, or you can highlight your data first. Data highlighted, and then I want the box and whisker plot. I will go here for all the charts. Then I find the box and whisker here. So I want to add the label so that I can see the number summaries. The next question is to find the interquartile range, which is Q3 minus Q1. Q3 minus Q1 is 43 minus 23 across to 26. Investigate for outliers. Investigate for outliers, multiply the interquartile range by 1.5. We get 39. Subtract it from Q1. If you subtract it from Q1, that is 23 minus 39, you get a negative number. No value is less than that. So there's no lower outlier. Then you do 49 plus 39, you get 88. There is no value above 88. So there's no upper outlier. So for this data set, there is no outlier. Now we want to determine if this graph is symmetric, skewed to the left, or skewed to the right. You can observe that Q1 is closer to, Q2 is closer to Q1 than it is to Q3. So it is at the left part, it is skewed to the right. It is at the lower part, it is skewed to the right, or positively skewed. If it was at the upper side of that box, it will be closer to Q3, that is to the right side of the box, or the upper side of the box. It will be negatively skewed or skewed to the left. So the last question is just what we did. If you add the same number, you will still get the same IQR. It's a measure of variation. The IQR will not change. Q1, Q2, Q3 will change because you will shift the values, but the difference between them is not going to change. Yes. Skew to the right. It's like the opposite. If it goes below, skew to positive skew. If it goes up, negative skew. That's why I like the horizontal box. If it is to the left, positively skewed, or skew to the right. If it is to the right, skew to the left. Just have that in mind. So your questions for the exams are going to be similar to this. Some of the questions might not be on the exam, but questions on the exam will be like these ones. So make sure you come with your charger so that you don't get out of charge unless you trust your battery. And okay. We are good for the day. You can sanitize.
I'm so sorry. I completely forgot about that.
And if you have any questions, send me an email. We can always arrange to make a Zoom meeting if you need one before the exam, especially tomorrow.